Okay, here we have is my project, and it's going to be covering the maximization profit on a gas company. Alright, so our original problem has, we have supplies for nitrogen, hydrogen, and chlorine, all which are a limited value. We produce, currently, gas and chloride. Right now, we only have one customer with no buying limits, so they will buy as much as we produce, and they have no other constraints. So whatever we make is what they buy, and what we can buy. Alright, and here's our original linear algebra problem. Here you see it is quite simple. There's you have your first gas that we make. So this is going to be our custom gas, and then we have our chloride, and then here we have our stock limitations. So the changes I've made is now that we have a new customer because our business is expanding. This new customer requires a new type of product, which is going to be oxygen. Oxygen is made from the process of gathering nitrogen. Previously, we just did not store it, and we didn't have any setup costs, and we let it go. So this customer will only buy from us if we make oxygen. They do want to buy other products as well. Now, producing oxygen does require a setup cost because you have to capture it and store it. Alright, and here I have a chart with a good breakdown of how the LP is going to look. I split off our two customers, so each of them has a custom gas and a chloride, and then only our customer 2 has oxygen, as customer 1 was not interested in buying it. And it is a blending problem, so each of these gases require some mixture of nitrogen, hydrogen, and chlorine from manufacturing. And then we also have our supply down below, and then our supply doesn't change. Alright, so here's the modified LP. Here we see that I've added a check to see if the customer 2 has chosen to purchase from us, or if we chosen to manufacture oxygen, which would cause customer 2 to purchase from us, and that would be K. And here's our setup cost of $500, and then we have our the binary limitation for that, and additional demands and limitations for customer 2 changes. Customer 1 didn't change all that much. Alright, I went ahead and made a flowchart of sorts, and it's very close to our networking problem. I found it was much easier to visualize in this format. This does have a decision for customer 2, like I said earlier. If oxygen, then you can make chloride, but there is a setup. Here we have our supply on the left, which is negative, and then these are big M because they are not going to limit themselves in how much they're going to buy, and then how much each of these products we are selling cost to the customer. These numbers are also the weights of how much nitrogen it takes to make our gas, or nitrogen takes to make the oxygen. So here we have some code that I try to run. I try to do this in an if-then statement. It made more sense to do it this way, as it was literally if this guy buys oxygen, then he'll possibly buy chloride. I wasn't able to get this to work properly. I was fighting the syntax the whole time, so I decided that it would be better to do it in a more mathematical way, similar to my linear algebra problem where I have a test variable. You can see that this test variable, which would be my linear algebra problem, a K, and you see I assigned it to the word test. Here we have the maximization and the constraints. I did make sure that everything was put into a data file. I also made sure that you have to choose either 1 or 0 for this to run properly. This is already an integer, so you can't go negative, and it has to be equal to or less than 1. And so if you put it anything else than 1, it won't work. And here we have our productions of gas of stuff, and you can see you can still see where I split it off between 2 customers. And then here we have our results. The interesting thing is that we did in fact choose to make gas, to make the new oxygen, despite the product, despite the setup cost. So that was pretty cool. And it looks like we produced everything for each customer. I did limit the product production to chloride and oxygen only for customer 2, because that's all they wanted, and they weren't interested in the custom gas. Alright, so our new model did run slower than our old one. I think it would have run a little bit faster if I was able to run the if too, and I didn't have so many, or if then, and I didn't have to deal with so many variables as I did, or that extra test variable. I think it could have been more optimized. But either way, I believe it would have run slower than the original model, because I've definitely made it more complicated. Alright, then that's my presentation. Thanks.